In 2025, NASA is poised to make significant advancements in lunar exploration as part of its Artemis program, which will enlist the expertise of over 1,500 engineers and scientists. This ambitious initiative aims to establish a sustainable human presence on the Moon and lay the groundwork for future manned missions to Mars. Overview of the Artemis missions. 1. Artemis II, scheduled for September 2025. Artemis II will mark NASA's first crewed mission to orbit the Moon. The primary objective is to test critical life support systems aboard the Orion spacecraft, ensuring astronaut safety while collecting vital data for subsequent missions. 2. Artemis III, planned for September 2026. This mission is expected to land astronauts near the lunar South Pole, making history by allowing the first woman and a person of color to walk on the Moon. 3. Artemis IV, set for 2028. This mission will focus on the first crewed operations at the Gateway Lunar Space Station, which will serve as a vital outpost for future lunar and Mars exploration. Key technologies. NASA's lunar missions will feature several groundbreaking technologies aimed at overcoming challenges associated with lunar exploration. Electrodynamic Dust Shield (EDS). This innovative technology will help to manage the pervasive issue of lunar dust, which has historically complicated missions. The EDS will employ electric fields to repel and prevent hazardous dust accumulation on surfaces. Stereo camera for Lunar Plume-Surface Studies (SCALPSS). This camera system will analyze how rocket plumes interact with the lunar regolith during landings, providing critical insights into surface behavior and erosion. These technologies will be tested during the Blue Ghost Mission 1, launched on January 15, 2025, with a targeted landing on March 2, 2025. This mission aims to gather data on lunar dust and surface conditions, essential for planning future landings and operations. Integration and collaboration. A cornerstone of NASA's Artemis program is its emphasis on collaboration with commercial partners and international agencies. The success of the Artemis missions will rely on integrating capabilities from various providers such as SpaceX for human landing systems and Blue Origin for next-generation spacesuits. Common themes across sources. The coverage of NASA's lunar missions reveals several recurring themes. Focus on safety. All sources highlight that astronaut safety is the foremost priority, especially as NASA navigates new technologies and operational challenges. Technological innovation. There is a strong emphasis on developing and utilizing cutting-edge technologies to mitigate dust and analyze surface interactions, which are vital for both lunar and Martian missions. Collaboration and partnerships. The importance of teamwork among various stakeholders, including industry partners and international collaborators, is a consistent theme across reports. Differences in sources. While the sources share a common narrative, they diverge in focus. Source 1 emphasizes technological aspects related to lunar dust and provides specific details about the Blue Ghost Mission 1. Source 2 offers updates on the timeline and operational challenges of the Artemis missions, placing significant weight on crew safety and system integration. Source 3 provides a broader overview of lunar missions without delving deeply into specific technologies or operational details. Timeline of events. January 15, 2025, launch of Blue Ghost Mission 1 aboard a SpaceX Falcon 9 rocket. March 2, 2025, targeted lunar landing for Blue Ghost Mission 1. September 2025, scheduled launch for Artemis II, NASA's first crewed mission to orbit the Moon. September 2026, expected landing of Artemis III on the Moon's surface. 2028, planned Artemis IV mission to the Gateway Lunar Space Station. Conclusion. NASA's 2025 moon landing mission represents a pivotal step towards sustainable lunar exploration, emphasizing safety, technological innovation, and international collaboration. By leveraging the expertise of over 1,500 engineers and scientists, NASA aims to establish a lasting human presence on the Moon and prepare for future missions to Mars, ultimately expanding humanity's reach into the universe. The Artemis program not only serves as a platform for scientific discovery but also embodies the spirit of global cooperation in the quest for knowledge beyond our planet. Counterintuitive information identified. 1. Safety versus innovation. While NASA emphasizes astronaut safety as its top priority, the need for technological innovation and the integration of new systems may pose unforeseen risks. The adjustments to the Artemis schedule due to challenges with new technologies like environmental control systems indicate that even as safety is prioritized, the complexities of innovating for space can introduce significant unpredictability. 2. Dust as a major challenge. The extensive focus on lunar dust and its mitigation might seem overly cautious given past lunar missions. However, it is counterintuitive to consider that something as seemingly benign as dust can pose significant risks to equipment and human life, illustrating how the mundane can become critical in extreme environments. 3. Interdependence of Moon and Mars missions. The assertion that technologies developed for lunar missions will significantly benefit Mars exploration might be expected, but the extent of this interdependence is often underestimated. The challenges faced on Mars, such as regolith management, are not merely similar to those on the Moon, they are unique and complex, highlighting that lessons from one environment cannot always be directly transferred to another. For commercial partnerships, the reliance on commercial partners like SpaceX and Blue Origin might seem advantageous for efficiency and innovation. However, it is counterintuitive to think that this partnership model can also lead to potential delays and complications, as seen with the need for extended time for testing and refinements of their systems, which ultimately affects NASA's timelines and mission readiness. 5. Global collaboration versus national pride. The narrative around NASA's Artemis program often emphasizes national achievement and space leadership. However, the heavy reliance on international and commercial partnerships counterintuitively suggests that successful space exploration is increasingly a collaborative global effort rather than solely a national endeavor. 6. Learning from the past. The Apollo mission's experiences with dust and environmental challenges are being used to inform new technologies, which may seem logical. However, the fact that these lessons are still relevant decades later underscores a counterintuitive reality. The challenges of space exploration are persistent and not fully addressed despite historical precedents. 7. Technological failures. The adjustments to the mission schedules due to failures in technology like the heat shield issue from Artemis I reveal a counterintuitive aspect of space exploration, that cutting-edge technology can lead to setbacks rather than advancements. This highlights the unpredictable nature of innovation in high-stakes environments. 8. Complexity of missions. The increasing complexity of missions from Artemis II to III and beyond may imply that each subsequent mission will build on the last. However, the reality is that this complexity can also introduce new risks and unanticipated challenges, contradicting the assumption that progress is linear and cumulative in space exploration. 9. Long-term versus short-term goals. While the Artemis program is framed as a long-term campaign for lunar and Mars exploration, the ongoing operational challenges and delays suggest that achieving these lofty goals may be more precarious than anticipated, revealing a potential disconnect between strategic vision and practical execution. These counterintuitive points illustrate the complexities and unpredictable nature of space exploration, where safety, technology, and collaboration must all be carefully balanced against the inherent risks and challenges of venturing into the unknown. In the context of NASA's groundbreaking 2025 moon landing mission, several key aspects may be overlooked by the general public, yet they hold significant importance for the success and future of lunar exploration. Here are some of those crucial elements, along with explanations of their significance. 1. Technological advancements in dust mitigation. One of the most critical challenges for lunar missions is the pervasive lunar dust, which poses risks to both equipment and astronauts. The Electrodynamic Dust Shield (EDS) and the stereo camera for Lunar Plume-Surface Studies (SCALPSS) are two technologies that will be tested during the Blue Ghost Mission 1. Significance. The importance of these technologies cannot be overstated. Lunar dust is not just an inconvenience, it can damage sensitive equipment, interfere with life support systems, and pose health risks to astronauts. The EDS uses electric fields to repel dust, potentially revolutionizing how we manage dust during landings and surface operations. Understanding dust behavior through SCALPSS will allow for better predictive models that enhance mission planning and execution. This is especially relevant for missions that will carry heavier payloads in the future. 2. Emphasis on safety and lessons learned. NASA's commitment to astronaut safety is a major theme throughout the Artemis missions. The adjustments to the schedules for Artemis II and III are largely driven by the need to resolve technical challenges and ensure that all systems are thoroughly tested before crewed missions. Significance: this focus on safety reflects a mature approach to space exploration, acknowledging that the unknowns in new technologies can pose serious risks. By taking the time to learn from the Artemis I mission, which highlighted issues with the heat shield, NASA is not only prioritizing the safety of its astronauts but also developing a culture of thoroughness and responsibility that is essential for long-term exploration. This careful approach could serve as a model for future missions to Mars and beyond, where the stakes will be even higher. 3. International and commercial partnerships. The Artemis program is characterized by significant collaboration among various stakeholders, including international partners and commercial entities like SpaceX and Blue Origin. This integration is essential for the ambitious goals of the Artemis missions. Significance: the collaborative framework established by NASA for the Artemis missions is indicative of a new era in space exploration where partnerships are critical for success. By leveraging the expertise and capabilities of commercial partners, NASA can expedite innovation and reduce costs, making lunar exploration more sustainable. This cooperative model could pave the way for future international missions, fostering a spirit of collaboration that is crucial for tackling the immense challenges of space exploration. 4. Gateway Lunar Space Station. The Gateway Lunar Space Station planned for Artemis IV represents a new approach to sustainable lunar exploration. It will serve as a staging point for missions to the lunar surface and beyond. Significance: the Gateway is not just a support structure, it symbolizes a strategic shift in how NASA envisions long-term human presence on the Moon. By establishing a base of operations in lunar orbit, NASA can facilitate more complex missions, conduct scientific research, and prepare for deep space exploration, particularly missions to Mars. The Gateway will enable a continuous presence on the Moon, which is vital for gathering data and testing technologies that will be crucial for future interplanetary travel. 5. Cultural and societal impact. The Artemis III mission is poised to make history by landing the first woman and the first person of color on the Moon. This aspect of the mission is often highlighted but may not be fully appreciated in terms of its broader implications. Significance: the diversity of the crew represents a significant cultural milestone that extends beyond space exploration. It reflects a commitment to inclusivity and equality in fields historically dominated by a homogeneous demographic. This aspect of the Artemis missions can inspire future generations, particularly underrepresented groups in STEM, to pursue careers in science and engineering. The societal impact of such representation is profound, as it can lead to increased diversity in future missions and promote a broader range of perspectives in solving complex problems. 6. Sustainability for future missions. NASA's long-term vision extends beyond the Moon, laying the groundwork for human expeditions to Mars. The lessons learned and technologies developed during the Artemis missions are designed to be applicable to future interplanetary missions. Significance: the strategic planning for sustainability indicates a shift in how space agencies approach exploration. Rather than viewing lunar missions as isolated events, NASA is integrating them into a larger framework of interplanetary exploration. This holistic view is essential for the success of future missions to Mars, where the challenges of survival and resource utilization will be even more pronounced. Establishing a sustainable presence on the Moon will provide vital insights and experience that can be directly applied to Mars missions. Conclusion. In summary, While the overarching goals of NASA's Artemis program are well publicized, the underlying details such as dust mitigation technologies, safety prioritization, international partnerships, the establishment of the gateway cultural milestones, and sustainability efforts are often overlooked. Each of these elements plays a crucial role in shaping the future of not only lunar exploration but also the broader context of human spaceflight, making them significant for the ongoing narrative of humanity's quest for knowledge and presence beyond Earth. Here are the 4 most valuable points for in-depth analysis and discussion regarding NASA's 2025 moon landing mission as part of the Artemis program. 1. Technological advancements and innovations. The Artemis missions are at the forefront of integrating advanced technologies to tackle the unique challenges presented by the lunar environment. Notable technologies include the Electrodynamic Dust Shield (EDS) and the stereo camera for Lunar Plume-Surface Studies (SCALPSS). EDS aims to mitigate the pervasive issue of lunar dust, which has historically posed risks to equipment and astronaut safety. SCALPSS will investigate the interactions between rocket plumes and lunar regolith, providing crucial data for future landings and surface operations. Analyzing these technologies highlights how innovation is essential not only for lunar missions but also for future Mars exploration, as lessons learned on the Moon will directly inform strategies for navigating Martian dust and surface conditions. 2. Mission schedule and safety considerations. The timeline for Artemis II and III has been adjusted to prioritize astronaut safety and address technical challenges encountered during the preparatory phases. As Artemis II will be the first crewed mission to orbit the Moon, it is critical that all systems, especially life support and environmental controls, are thoroughly tested and validated. The iterative learning process from each mission is vital for minimizing risks in subsequent missions. This point emphasizes the importance of a methodical approach in space exploration where safety must always be the primary concern, especially as NASA transitions to more complex missions involving human presence on the Moon. 3. Collaboration and partnerships. The success of the Artemis program relies heavily on collaboration with commercial partners such as SpaceX and Blue Origin and international agencies. This partnership model allows NASA to leverage external expertise and technology, facilitating a more robust and flexible approach to lunar exploration. The emphasis on integrated capabilities showcases a shift in how space missions are planned and executed, highlighting the role of public-private partnerships in achieving ambitious exploration goals. Discussing this point can lead to a broader conversation about how collaboration across sectors can drive innovation and efficiency in space exploration. 4. Long-term vision for sustainable lunar presence and Mars preparation. The Artemis program is not just about returning humans to the Moon, it is about establishing a sustainable human presence and using the Moon as a testing ground for future Mars missions. The planned Gateway Lunar Space Station and the integration of in-situ resource utilization are key components of this long-term vision. Analyzing this aspect of the Artemis program can provide insights into the strategic planning required for deep space exploration and the potential for sustainable living in extraterrestrial environments. This point encourages discussion on the interplay between lunar exploration and Martian missions, including how technologies and strategies developed for the Moon can be adapted for Mars. These points encapsulate the technological, operational, and collaborative dimensions of NASA's upcoming lunar missions, offering a comprehensive framework for deeper discussion and analysis. 1. Apollo 11 Mission 1969. The Apollo 11 mission marked a historic moment in human space exploration when astronauts Neil Armstrong and Buzz Aldrin became the first humans to land on the Moon on July 20, 1969. The mission involved extensive collaboration among over 400,000 engineers and scientists across various organizations including NASA and numerous contractors. Apollo 11's success showcased the effectiveness of innovative technology such as the lunar module and the Saturn V rocket and emphasized the importance of astronaut safety and meticulous mission planning. The mission's objectives included scientific exploration and sample collection, laying the groundwork for future lunar studies. 2. Mars Exploration Rovers 2004, NASA's Mars Exploration Rover mission, which included the Spirit and Opportunity rovers, aimed to explore the Martian surface and gather data to determine past water activity on the planet. Launched in 2003 and landing in 2004, this mission involved a team of thousands of engineers and scientists dedicated to overcoming the challenges of remote exploration. The technological innovations developed for the rovers, including advanced robotics, autonomous navigation, and scientific instrumentation, were critical for the success of the mission. The collaboration with international partners and the scientific community helped in analyzing the data collected, significantly advancing our understanding of Mars. 3. International Space Station 1998-present. The International Space Station (ISS) represents a landmark achievement in global collaboration in space exploration. Launched in 1998, the ISS involves the cooperative efforts of space agencies from multiple countries, including NASA, Roscosmos, ESA, JAXA, and CSA. The station serves as a microgravity research laboratory, allowing scientists to conduct experiments across various fields, including biology, physics, and materials science. Over 1,000 engineers and scientists contribute to the ongoing operation and research aboard the ISS, emphasizing the importance of teamwork and innovation in achieving long-term goals in space. The ISS has also laid the groundwork for future human exploration missions to the Moon and Mars. Future outlook: predictions for NASA's 2025 Moon landing mission and beyond. As NASA approaches its ambitious 2025 moon landing mission, the Artemis program is set to revolutionize human space exploration. With over 1,500 engineers and scientists collaborating on this initiative, several critical predictions can be made regarding the future of lunar exploration and its implications for Mars missions. 1. Technological innovations and advancements. The Artemis program will likely lead to significant technological advancements, particularly in areas crucial for lunar and Martian exploration. Key innovations such as the Electrodynamic Dust Shield (EDS) and the stereo camera for Lunar Plume-Surface Studies (SCALPSS) represent just the beginning. These technologies are expected to improve not only lunar operations but also provide valuable insights for Mars missions, where dust management is equally vital. As NASA continues to refine these technologies, we can expect more efficient systems that can withstand the harsh environments of both celestial bodies. 2. Increased international collaboration. The Artemis program emphasizes international and commercial partnerships, which will likely expand in future missions. Countries and private companies are expected to collaborate more closely, sharing expertise and resources. This trend will foster a global approach to space exploration, enabling missions that are more inclusive and diverse. We can envision a future where international crews work together on lunar bases, setting a precedent for cooperation on Martian expeditions. 3. Sustainable lunar presence. The goal of establishing a sustainable human presence on the Moon by the end of the decade will influence future lunar missions significantly. NASA's plans for Artemis IV and beyond will likely focus on constructing infrastructure such as habitats and research stations that can support long-term stays. This sustainable presence will serve as a testing ground for technologies and life support systems, ultimately contributing to the feasibility of human life on Mars. 4. Expanded scientific research opportunities. The scientific output from the Artemis missions will enhance our understanding of lunar geology, resources, and history. The data gathered through missions like Blue Ghost Mission 1 will provide insights into the Moon's regolith, essential for planning future landings. The findings will not only inform lunar operations but will also have implications for resource utilization on Mars, as scientists will study similarities and differences between the two environments. 5. Mars exploration preparation. The Artemis program is a stepping stone for Mars exploration. As NASA develops and tests technologies for the Moon, these will be adapted for use on Mars. The challenges encountered during lunar missions will provide critical lessons that can be applied to Mars missions, particularly in areas like dust mitigation, habitat construction, and life support systems. The timeline for Mars missions will likely be informed by the successes and lessons learned from the Artemis program, with a potential crewed Mars mission targeted for the late 2030s. 6. Human factors and safety protocols. Safety remains a top priority for NASA, especially as the agency embarks on crewed missions. The Artemis II mission will provide vital data on life support systems and environmental controls, which will be crucial for ensuring astronaut safety on future missions. As technology advances, we can expect improved safety protocols and systems designed to respond to unforeseen challenges, ultimately fostering a safer environment for astronauts on lunar and Martian missions. 7. Commercial opportunities in space. The Artemis program is likely to stimulate commercial interest and investment in space exploration. As NASA collaborates with companies like SpaceX and Blue Origin, we can anticipate a rise in commercial lunar landers, rovers, and habitats. This burgeoning industry will not only support NASA's missions but will also pave the way for private ventures, including lunar tourism and resource extraction, creating a new economic landscape in space. 8. Public engagement and inspiration. With the return to the Moon and the prospect of human missions to Mars, public interest in space exploration is expected to surge. NASA's efforts to include diverse astronauts and highlight their journeys will inspire future generations to pursue careers in STEM fields. Increased public engagement through educational initiatives and media coverage of lunar and Martian missions will foster a culture of exploration and curiosity. Conclusion. As NASA gears up for its 2025 moon landing mission, the implications of these efforts extend far beyond lunar exploration. The Artemis program is poised to redefine human spaceflight, set the stage for sustainable lunar habitation, and prepare humanity for the next giant leap to Mars. Through collaboration, innovation, and a commitment to safety, NASA is not only embarking on a journey to the Moon but also laying the groundwork for the future of human exploration across the solar system.